In this example, we're going to do data and tool blending with KNIME. The business challenge is the following. We wish to create categories and forecasts for planning and pricing purposes around energy data. There's 1.5 years of data for 6,000 businesses and households. It's 170 million records given to us courtesy of the Irish government. The technologies used, there's quite a variety, but it's all going to be managed and controlled from the KNIME Analytics Platform. Let's take a quick look at how we're going to break down this task. On the left, you see our workflows. Those are the different task steps we're going to have. We're going to do a model learning step, a deployment step. Then we're going to use that deployment in simulation. We're also going to do some model management, and last but not least, we're going to take a look at the web portal and how casual users could access all of this. Now, very, very important for this demonstration is the fact that the data is not contained locally. It is on the Amazon cloud, and all of that vast quantity of data will be managed on the cloud in this example. Now, one last thing, we're using KNIME 3.0. This is the newest production release of KNIME. It has a very modern, fresh look and feel, and we're very proud of it. I hope you like it. Let's dive straight in and take a look at the learning workflow. Here we've broken it down into 3 steps associated primarily with the different technologies we're going to use. Step 1, the data. We're actually accessing the data in Hive up on the Amazon cloud. In this particular example, we're using a Cloudera infrastructure. We could have used Hortonworks or one of a couple of others that are fully supported. In this case, we connect to the data up on Hive. And the most important thing is here in the middle section, where we're going to create new features. What we're doing is creating 32 new features based on the data. We're going to take the individual transactions, combine them, and create those features per meter, per household and business. And it's a lot of the classic things you would expect: daily, monthly, yearly statistics, etc., etc. What's interesting here is that we are not actually physically passing the data from one node to the next. Instead, we're creating SQL. Now, you could manually put SQL into this example. However, we find combining with KNIME's node environment to be very powerful. Let's take a look at the data joiner. Now, of course, an SQL statement to join is very easy, but KNIME makes this much more pleasant by giving you all of the different fields that you could choose to join. A very easy example, but something that makes SQL a lot more satisfying. But the real power comes when we combine it with other KNIME nodes. For example, the group by node. The group by node is incredibly powerful, and in this configuration window, not only can we decide how to summarize and group different fields, but we can then manually aggregate all the fields on a wide variety of aggregation techniques. This makes it very easy to mix and match and create exactly the sorts of information you need from the data. Now, of course, you can do this sort of thing in SQL, but it's a lot of work. You can see what we've done here is pull the power of KNIME nodes together with that of Hive. Now, in the middle, we're not physically running those nodes. We are pulling all of the SQL together. The SQL actually doesn't get executed until the end, over here with what we call the database connector table writer. That is where the collected SQL from all of these nodes goes together and is physically executed in Hive on the Amazon cloud. Very, very efficient, and the way that Hive should be used. Our very last step is to take that new data and save it in a temporary Hive table in preparation for loading into Spark. We've now completed step 1 of our learning workflow. Let's dive into step 2 and take a look at Spark, also running on AWS, the Amazon cloud. You'll recall that we prepared our data in Hive. So the first thing we do is we take that Hive data and expose it to Spark in what's called a Resilient Distributed Dataset, an RDD. It's what gives us the power in Spark. Now, anytime you have data, you need to transform it, of course, and Spark does certain things well, but we've discovered there's actually a few limitations still in Spark. One of them is handling missing values. So here's where we use the power of KNIME. We're going to take the definition of the Spark table and transfer that definition into KNIME. Notice that's why there's that little warning sign there, because we're not physically passing data at all. That physical specification gets passed into the KNIME missing value node, a very, very powerful way of defining the rules for handling missing values. We take that node and pass out a PMML. Yes, indeed, this is the famous PMML language. It is not a model of a predictive model. It is a model of a transformation. PMML, the new standard, allows for that, and our users tell us KNIME may be the only package and platform that can actually take advantage of it. Here's where you see its power. We're creating a model in KNIME, passing it back to Spark, where that PMML model is actually executed on Spark. An elegant way of overcoming some of the shortcomings of Spark. At the end, we need to take that specification, that Spark data, and make sure it's saved for further processing. And here we pass that into another RDD using a very simple KNIME node. That data is now available for parallel processing in the next section. A parallel parameter sweep. Let's dive in. Here you see it. We've got two loops. The outside loop, the parallel trunk start, is where we tell Spark how many different parallel processes we want to use. Now this is important because you've got to balance performance with the cost of running things in the cloud. We've chosen 10. What we then do is fairly classic. We go in and do a parameter sweep. We are trying to come up with the ideal number of k-mean clusters. You'll notice that we're using the mlib k-means from Spark to actually do that performance in the cloud. With each of the combinations, we need to come up with the best cluster quality, and we'd like to just take a look at that quickly. Spark is good at some things. For example, at the top, we're actually joining those clusters back to the original data. But when it comes to actually testing the performance of each cluster, what we've now got are literally thousands of very small data sets that need to be tested. Spark has an overhead, and when you're doing things on small data sets, that doesn't work so well. So we've used the power of KNIME to move those small data sets into KNIME to do our testing of quality for the different cluster groupings. At the end, we collect all the different K clusters and all of the different parameters, and we select the best model. In our model, it turns out that 13 clusters was ideal for this particular data. It's that model that we pick up and save for further use later on. We now go to the third part of our step 2, applying the model. This is exactly what you would expect. We've created an accurate PMML model for our 13 clusters, and we apply that to the original data back up in Spark. Very straightforward, very easy to do. We're now going to move on to step 3 of our learning workflow. This is where we're going to calculate one regression model per cluster. We start by taking our defined clusters and pull everything back together, because what we need to do up in Spark is come up with a representative usage time series, and we do that here in the nodes at the top using the power of Spark. But now, instead of 170 million records, we've reduced that down to 170,000 records, a very, very small set of time series, 13 of them, that we can process. We've decided to process them locally, so we transfer that data from Spark into native KNIME to do a loop for each one of the 13 sets. Why are we doing this? Efficiency and the fact that Spark cannot yet do a polynomial autoregression. But we're also doing it because we want to blend it and bring in other data. Since this is Irish data, we want to pull in information about the Irish holidays and use that data in our polynomial autoregression. We run that, we come up with a model for each one of the 13 clusters, which we can use for energy prediction and also, for example, for pricing. We take those models and write them out into the table. We now move to model deployment. This is where we're going to take the models that we've created and apply it to unknown data. We've packaged this using JSON. In that way, we can access the workflow not only from KNIME, but also externally. Anything that can access JSON or REST services would be able to call this particular workflow. We do a transformation, a pre-processing of the data, and we do our prediction, because of course it's unknown data. In all cases, we're using the PMML models that we've already created in our learning exercise so that we know we have very accurate models. We're collecting information about this particular workflow, usage statistics, which of course are very important when you're running up in the cloud to figure out what is the best mix and match. We move to simulation, where we actually call that particular workflow here locally. That's so that we can do our testing. But of course, that local calling of a deployment workflow is not really what it's all about. You need that deployment workflow up on the server. That's very, very easy to do in KNIME. We're going to simply grab that model deployment workflow, click, drag, and drop it up on the KNIME server. In this case, it's located on the Amazon cloud. Now it's available to all of the different services that I've already mentioned. Elegant, simple, straightforward. I'm going to quickly show you an example of model management. This means many things to many different analytics companies, but in this example, we're going to show a fact that sometimes is missed. As we build models using these different tool bases on the cloud, local, and server, we now need to come up with decisions about where best to run. With those statistics, we can pull everything together at KNIME and actually show that visually. Here, I'm using the BERT, Business Intelligence Open Source tool, to do that in a very simple way, but of course, all of those statistics about building and maintaining the models are available for later use. We're now going to move to our last workflow, which is the web portal workflow. You see, many platforms need to leave their environment to package things for end users on the web. Not so in KNIME. We can use the same node and workflow analogy to package and present onto the web. As you can see here, we're calling our local workflow for deployment. And when we jump to the web, we can make this particular workflow available. You log in this example, we've kept it very, very, very simple. With authorization, you can go click on the workflow and run the workflow. In this particular example, we're going to choose the example I just showed you and open it up. It gives us choices where it guides us through. In this case, we have a new client with data. We want to get that data scored so that we can know what cluster and what price plan is available for that particular customer. We upload the data that we've chosen. It is pulled into KNIME up on the cloud in this particular case. And when it's loaded, we can go to the next step and actually run our analysis. What you see here first at the top is the cluster, the price plan, and various interesting graphical representations of what we've learned about that particular customer. This simple example can be enriched quite a bit with what's called quick forms and flow control, where we can really interact with the end user. Just a very simple example, though, to show you the concept in action. That completes our little demonstration. We've covered quite a bit. Let me summarize quickly. We've used a number of KNIME technologies. First, the KNIME Analytics Platform, version 3 with its new look and feel. We've enhanced that with extensions for the KNIME server, the Big Data Connector, and the Big Data Connector for Spark. In that way, we've been able to mix and match Hive, Spark, mlib, and Cloudera. We've shown JSON as well as the local and server combinations, all combined with the Amazon cloud. I hope this has been interesting for you. If you want more information, check out the website, or better yet, download KNIME and try it yourself.